In this video, we're going to be looking at the idea of reference angles. So every angle, no matter where it is, how big it is, how small it is, whether it's positive or negative, has a reference angle. And a reference angle is the acute angle formed by the terminal side and the x-axis. So those are a couple of key things to think about. The acute angle formed by the terminal side and the x-axis. Now, I'm going to just do a quick example just to show you, okay, here's my xy axis and I'm going to draw an angle here. So here's an angle that I've just created. Well, by my definition, the reference angle is the acute angle formed by the terminal side, here's the terminal side, and the x-axis. Now the x-axis, to make it an acute angle, meaning less than 90, I'd have to use the x-axis that's over here. So here would be my reference angle. Another quick example. Maybe I've got an angle that looks like so. So now the reference angle would be the acute angle formed by the terminal side and not the y-axis but the x-axis. So here would be the reference angle. It's a little bit different, but it's always acute, meaning less than 90, and it always involves the terminal side and the x-axis. Might be the positive x-axis, might be the negative x-axis. So back to this. My reference angles will vary depending on the quadrant in which the terminal side finishes. So if I have quadrant 1 is where my angle is. So I'll put my initial angle here. We'll call this angle theta that we've just created. Well, angle theta in the first quadrant has a reference angle that is exactly the same as that particular angle. Because what I need to do is make an acute angle with the terminal side and the x-axis. Well, guess what? That's the exact same angle. Now, when we talk about reference angles, sometimes you'll see theta prime as a way to notate that we're working with a reference angle. So we've got theta is the original, theta prime is the reference angle. So notice it's the exact same thing when we're in the first quadrant. If my terminal side lies in the second quadrant, so remember we number our quadrants 1, 2, 3, 4. If my terminal side is in the second quadrant, like one of the examples I did, here's theta. My reference angle is the acute angle formed by the terminal side and the x-axis right here. Here's theta prime, the reference angle. Now, if I wanted to find the measurement of that reference angle, well, common sense tells me, well, I went this far, however many degrees this might be, but I'm short of 180. So I have to figure out what's the difference between 180 degrees and the angle that I had. When I say, well, what's the difference between them? Well, that means subtraction. So what I would do to find the reference angle is take 180 degrees minus whatever the initial angle might have been. And that's what my reference angle might be. Now, if I'm in radian measurement instead, well, that 180 degrees just changes to pi. Pi times theta equals theta prime, the measurement of the reference angle. Third quadrant is next. 1, 2, 3. I'm down here in the third quadrant. Here I have angle theta. As I look for theta prime, the reference angle, again, it's the terminal side and the x-axis and the acute angle that they form. So here would be theta prime in this case. So how would I find the measurement of that angle? In this case, I've gone 180 degrees, but then I go some extra. So I want to figure out how far past 180 degrees have I gone. So I take the difference between the angle and 180 degrees. So I went past it, so I subtract 180, that gives me theta prime. If I'm working in radians, I'm subtracting pi radians to come up with my reference angle. Last quadrant is the fourth quadrant. If I have a reference or a terminal side that ends up in the fourth quadrant, like so, there's theta. My reference angle is the acute angle, again, formed by the terminal side and the x-axis. Right here is our reference angle, theta prime. In this case, if I want to find the measurement of theta prime, well, to go all the way around the circle would be 360 degrees. I came up short. So how short of 360 degrees am I? Well, to find that out, I take 360 degrees and I subtract whatever my angle might have been, and that will give me the reference angle. If I'm working in radians, I take 2 pi minus that angle, and that equals theta prime, my reference angle. So let's put that idea to work as we sketch a couple angles and find some reference angles to go with them. So first of all, sketch the angle, find a reference angle for an angle negative 295 degrees. Putting my angle in standard position, I start with the initial side of the positive x-axis. Since it's negative, I need to rotate clockwise. So I rotate clockwise, let's see, here's 90 and 180 and 270 and a little bit more. And that's my estimate for what negative 295 degrees might look like. So my reference angle is the acute angle formed by the terminal side and the x-axis, so that'd be right here, there's theta prime. So I just have to think to myself, well, I went around 295 degrees in the wrong direction. To get all the way back there would have been 360, so I'm going to use this idea. I'm going to take 360 and subtract 295 degrees to figure out what's the difference between those two. Well, that's going to end up being 65 degrees, which means my reference angle is 65 degrees. That's the acute angle that's formed right here. Now, the next example, we're working with an angle in radian measurement. So 7/12 of pi. First of all, when I sketch this, 7/12 of pi might be a tricky thing. I don't know where it is. Maybe I convert it to degrees first, then plot it, and then figure it out. But again, if you say it as a fraction, 7/12 of pi. Think about how does 7/12 compare to something that I know, like half of pi. I know half of pi is right here at 90 degrees. I know 1 pi is right here. I know 3/2 pi is down here. I know this is 2 pi. So 7/12 is a little bit bigger than 1/2, right? 6/12 would be 1/2, 7/12 is a little bit bigger. So when I draw that initial angle, put my initial side here, and I'm going to draw 7/12 to be just a little bit beyond 1/2. Because 7/12 is just a little bit bigger than 1/2. And now when I find my reference angle, it's again the acute angle formed by the terminal side and the x-axis. Well, here we go. I can think about how short of pi am I. Now, pi is, I have half of pi here, a full pi here. I have 7/12 of pi. Well, how many more 12ths do I need to get to a full pi radians? Well, that's going to be 5/12 of pi. Now, if that doesn't work to do that in your head, you could always do a little bit of subtraction. We're going to take pi minus 7/12 of pi. And now, because I'm subtracting a fraction, I need common denominators. Well, this would be the same as 12/12 of pi minus 7/12 of pi. 12 pi minus 7 pi is 5 pi over a common denominator of 12. So again, you could probably figure that in your head potentially, and if not, just write it out and solve that particular fraction subtraction problem. And that'll do for reference angles.